Hi, y'all. So some of you missed our lab today, and so I'm just going to let you know that I'm getting ready. I'm going to put my lab coat on, and if you missed this, we're going to try to go through it step by step, all right? So I got my official lab coat on, let you know that I'm playing scientist today. And today I'm going to just kind of move my screen around a little bit. We are going to be working with physical versus chemical changes, right? So I bet you most of you hopefully learned a little bit from the mystery science piece, all right? But today we're going to talk about something different, all right? So maybe you know this, maybe you don't. What's the difference between a physical and a chemical change, okay? So I'm just going to pause it and hopefully you can say something out loud to your. Okay, now we're going to start back up again. So I'm going to give you a few examples, all right? So I'm going to take a piece of paper here. My lab table's back here. This is my school lab table. And I'm just going to crumple this piece of paper up. There it is, right? Physical or chemical? Hopefully you said physical. And hopefully you might say, Mrs. Sweigart, nothing changed. It's still a piece of paper. Got it? Okay. So put that one aside. Now, I'm going to take another piece of paper. I actually can't do this inside because my office, my lab is set up in a bedroom situation and it will set off my smoke alarm. But if I set this piece of paper on fire, okay, and it burns up, will I still have a piece of paper? No, I'll have a bunch of ashes. So I completely changed the substance. I do not have paper anymore. I have a bunch of ashes, okay? A little bit like the logs in your fireplace, if you have a real fireplace, or when we burnt the logs at Green River in our fire. They didn't come back to logs, all right? So most of you know this experiment. If I took baking soda and vinegar, all right, and I add the two together, I'm almost 100% certain that you all know that when you do that, something happens. So I'm going to pause it. Hopefully you said, I'm pretty sure something happens. Most of you might say it fizzes, okay? Now that fizz is called something else, okay? I'm not sure if you know what it's called, but it starts with a big G, okay? And that leads us to our next experiment. So our next experiment is something, I'm going to get my paper all set up here so I don't have my wrinkles, all right? So remember when we made toothpaste, we used something else that had a calcium word in it, okay? It was calcium carbonate. So it was that little Tums and it was calcium carbonate. So today we're using a new chemical. It's called calcium chloride, okay? So I'm going to pause this so you can get a piece of paper and pencil and write these ingredients down on your paper, all right? So it's calcium chloride. There's its chemical name, which is CaCl2. There's baking soda, which you know very well. And then there's this new substance called phenol red, right? So here's my phenol red. That's what it looks like, all right? So I have a lot of this at school, but I just went online and I got it from Amazon. Don't go out and buy this. You do not need this, okay? It's very helpful in this lab, though. Then I actually had this in my bathroom cupboard, right? Now this is called damp red. Now damp red has a chemical in it. One of its very first ingredients on the back says calcium chloride, right? And one of the things that damp red does, it helps take moisture out. I think we talked about something about moisture before when we had glycerin, but it's a little bit different, okay? So we're going to be using damp red. We're going to use some of this, okay? And then we also need our very, very powerful and helpful baking soda, all right? So three things. I'm going to pause and make sure that you have got this down. Calcium chloride, baking soda, and phenol red. So just a little. Okay, I'm back. Now, here's what's going to happen. I need to make sure that you have written on your piece of paper, all right, a big H, and that stands for the hypothesis, okay? And here's what's going to happen, all right? I'm going to use a Ziploc bag, okay? And in that Ziploc bag, I'm going to put these ingredients, a little bit of each. Some Phenyl Red, some of our vinegar, really not vinegar, sorry, I got the wrong one. Some of our baking soda, and then some of our calcium chloride, all right? So it actually says up here on my sheet that I need to put in 1 teaspoon of baking soda. So here's my Ziploc bag, all right? Here's my baking soda. And it's very helpful to have 2 people do this lab. So if you were at school, you'd be having a partner. So there you go. There's my 1 teaspoon of baking soda, all right? Then it says I need 2, so I'll write this up here so you can see it. So I need 1 teaspoon of that, okay? For the calcium chloride, I need 2 teaspoons of that, all right? So I'm going to get my teaspoon measure out and get my this out, okay? And again, it's easier if you have 2 people, but I think we can manage, all right? So here we go. I need 2 of them. So, whoop. I don't want to spill this. Oh, I'll put it up here. Now I'll show you what this looks like, okay? It's very hard for you to see, but let me see if I can get it in the camera just so it looks like Dippin' Dots, okay? So I'm going to pour it in here, all right? That's not Dippin' Dots. It's not cold, okay? There's 1, all right? I'm going to reach over, sorry. And here's 2. So I have 2 of those. All right, so I got my 2 teaspoons of that. The last thing I need is this liquid, and this is a liquid called Phenyl Red, all right? Now, you probably don't know anything about this, but we're going to get into this, okay, when we get into acids and bases. And that's a hint to this experiment, but not the biggest hint, okay? So what I'm going to do is I'm going to measure, and it says I need to put 10 milliliters of Phenyl Red. 10 ml of Phenyl Red. So this is 1, this is 2 of that, okay? So I'm going to take this, open up my Phenyl Red, all right? And then I'm going to pour 10 milliliters, make sure I can see, right? Boop. Yeah, I got a little bit much, just a little tad more. There we go. All right, so put my Phenyl Red back over here, my fancy lab table. All right, now my Ziploc bag. Now here's what it's going to do, all right? I want to pour this into a vial, okay? Now a vial is just a little, it's like a pill container, okay? It could be anything, all right? Anything that, you can take the lid off. And I'm going to pour it in here. All right, I'll put this up here. Now, the next thing I'm going to do, all right, and this is what you have to do. You got to write your hypothesis. What's going to happen when I do this? All right, and hopefully you've already written your hypothesis. But I'll stand this up like this in the corner, very, very carefully. And I'm going to hold it at the bottom. I'm going to Ziploc this bag up really well. Gotta love Ziploc science. So much you can do with the Ziploc bag. All right, now, here comes the magic moment. Make sure you've written your hypothesis, right? And I'm going to tip it, okay? And when I tip it, there's a question here, and I want you to write down what you observe, okay? Anything that you see. All right, here we go. I'm going to really shake it up. All right, so there we go. That's the bag, right? Right? And hopefully you're getting a really good picture. So I'm going to turn it, just keep turning it a couple of times, right? I'm going to kind of turn it sideways so you can see what's happening to the bag, right? And I'm going to feel it. Now, this is the best part, okay? This feels actually kind of cold, okay? Yeah, there's a little chill in it, okay? I can feel some of the chunky stuff at the bottom, which, part of it mixture. Oh, I got look at that, red still there, right? hopefully you notice something about the bag, right? So obviously we have some yellow. Obviously everything got mixed up, okay? So we're never going to get that stuff back again. But look at the bag. It got pretty darn big or fat. It kind of blew up, okay? I love this lab because you're actually blowing up a Ziploc bag, okay? Look at the size of this thing, okay? So what do you think it caused? What do you think happened, all right? Do we have a physical change or a chemical change, all right? So I'm going to pause it, and I want you to just kind of say, what do you think happened? Was it physical, chemical? Okay, so we're back now. Remember when I said that G word, okay? So you probably said it looks like it's made fizzes, okay? It looks like it's got bubbles. That bubbly, all right, and that G word is what happens when you put the vinegar and the baking soda together also. It makes a gas, okay? So we have inflated the Ziploc bag. It is really fat. It looks like it's ready to pop, all right? I've done this lab a ton of times. I have never seen a bag pop yet, but that would be cool, all right? So our next set of questions is this. See? Didn't break, didn't pop, right? We'll set it up there for a minute. All right, here's our next set of questions. Chemists want to know which chemicals work together to create the new substance. Now, we got a lot of chemists out there working on trying to find out what happened with this virus. Think about what they're doing in their labs all the time, okay? So we need to know what actually was happening here. What created that gas, okay? So we got three questions. Was it the baking soda and the phenol red? So if I just took baking soda and phenol red and I mix those two together, would I get that gas? Okay, that's the first question. Or was it the CaCl2, the calcium chloride, and the phenol red? Or was it this one and the phenol red? Got it? And then the last one was, okay, the question is, what is the purpose of the phenol red? So I'm going to pause it. I want you to write down which one you think it is, okay? Which one do you think really caused the gas? All right, I'm just a little pause. Okay, now I'm back. So we're going to try, I don't know which ones you wrote down, okay, but we're going to try both of them just so you can see. So there's my baking soda. I'm going to put my baking soda. It said 1 teaspoon of that in there, okay? I got that. I'm going to measure out 10 milliliters of the phenol red because it says phenol red. There. Going to get another vial. So this is just a toothpick container. Pour it in there. In a Ziploc bag. And again, this is the baking soda and the phenol red. So here we go. Baking soda. Phenol red. Make sure I get it. Hold it. Got it. I think I got it. All right, ready? It's all in there. All right, so there it is. Okay. Looks like it's cold. Definitely has a chill to it. All right. And it looks just like red, almost red Kool-Aid. Okay, a red something. All right. Not much happening to the bag. All right. So that's what happened to that one. So now we will try the calcium chloride and the PR. All right. I'm going to get my measuring with a new bag. I'm going to put 2 in here because it said 2 in the beginning. That's an interesting question, that ratio. All right. There's 1. Okay. Near those Dippin' Dots, I'm trying to show you, but the best way I can. Okay. All right. Now measure out some more phenol red. I keep moving all my stuff all over the place. All right. Pour it in another. Here's my other vial. So I did try to get all my materials ready for you. All right. Ready? Calcium chloride, phenol red. Here we go. Zip it up. All right, got it? Okay. Let the old through. Oh my. Oh, it's a little warm. It's a little warm. A little warm, a little warm. Oh, but guess what? It did not do a whole lot to make anything gassy, okay? Maybe a little bit, but nothing compared to this one. Look how fat that one still is, okay? So our very last attempt at this, all right, is to figure out the purpose of the PR, all right? Now, what is the purpose of the red stuff, all right? We're gonna do one last one. This is closing the lab up, all right? So our last try, I want you to choose. So this is where you have to write something down. We're gonna get rid of the phenol red. We're gonna just say, now phenol red is a liquid. So what happens if we try water, okay? So I'm gonna say, would you like to try baking soda and water? 3 choices. Calcium chloride and water, or baking soda and calcium chloride and water, okay? So quickly, I'm going to pause it while I kind of get this set up and you write down which one you think is going to make the gas similar, okay? All right, here we go. You ready? Might have missed that part. I don't too. I'm not sure if I paused it or not. All right, here we go. We're going to do the calcium chloride and the water next. Okay. So I'm getting a new bag. Calcium chloride. 1, 2, 10 milliliters of water. Oops. 10 milliliters of water. Okay. Oh, I'm going to just put this in like this because I need that last vial. Because it doesn't matter as long as it's an open container. I'm going to put it in. All right, so this is the calcium chloride and water. Whoa. I have heat. I have heat. I have heat. Ooh, it is warm. Okay. I'm seeing a little puffiness too, just a little bit. Just a little bit. All right. So now we are ready to try the baking soda, the calcium chloride, and water. All right. So I'm going to pause it. All right. This is it. Very last one. I can get my Ziploc bag in there. All right. Ready? Ooh. On the last one. Baking soda. Got it. Calcium chloride. 1 teaspoon. 2 teaspoons. 10 milliliters of water. Here's the vial. This is number 3. Baking soda, calcium chloride, and water. Now, we got cold and we got hot. And remember, we're seeing, do we have a chemical reaction? And what actually is the combo that makes the chemical reaction? And what is the purpose of phenol red? So we've got lots of questions here. All right, take round and roll. Whoa. No color, just kind of white Okay, ooh, I see some bubbles. I see some bubbles. I see the bag getting a little puffy. Okay, I feel cold. It's puffy. It's got kind of like bubbles down here still, and it's cold, and the bag is puffing up. So we created a chemical reaction, but we have no color. So what's the phenol red for, right? So stay tuned because next week we're going to do something that's really going to talk a little bit more about the phenol red and what is its purpose, all right? So I'm going to be adding some questions to this lab, all right? And we'll ask you to have them ready for us for next week, okay? Hope you enjoyed that. This is your science teacher, Mrs. Sweigart, signing off. Bye-bye.